Um, so, women coding community is building a safe environment for women to thrive technically in tech industry. Women coding community mission, empowering women to be at the forefront of technology and innovations. Women coding community vision is empowering women in their tech career through education, mentorship, community building, and career services. We provide workshops, events, study groups, connect members with industry mentors, foster a supportive community through meetups and conferences, and also raise awareness for more inclusive industry practice. Our code of conduct. At Women Coding Community, we are committed to a vibrant, supportive community where women can network, share experience, and foster professional relationships, regardless of age, gender, visible or invisible disabilities, ethnicity, gender expression, level of experience, education, social economic status, nationality, personal appearance, race, religious, sexual orientation, or preferred programming language. Our project, we have a lot of projects, 3 active study group. One is the LLM study group, another one lead code study group, and system design study group at this moment. Yeah, we have a lot of mentors. We have long mentor program, and we have ad hoc session. We have many of Slack channels like AWS learning community. What we have ProcLead code channel. We have a lot. I don't really remember all of them. Yeah, so basically that's it. If you haven't joined us, so just scan QR code and join us, please. Yeah. So I will share another screen, and we'll introduce what we're going to learn today. Do you see my screen? It should be a whiteboard, right? Yeah, cool. So in today's session and next session, I just want to introduce you into form what is the system requirements at all, what is the functional requirements, and what is non-functional requirements. Under non-functional requirements, we have particular terms, which is we start to learn. We will cover them today, and we will cover them next session. All these terms include why it's important to know and understand, because all non-functional requirements in this term, when you define them, behind them, there is system design concepts like load balancing, caching, replication, sharding. All these system design concepts will be under non-functional requirements. And in order to succeed during the system design interview, or if you're designing something like features at your work, or you're designing some product, it's very important to understand first terminologies and what is this terminologies mean from the perspective how we can meet these requirements from the concept of system design, from the system design concepts. Is it clear what I just told? Okay, so cool. That you didn't lost when we will start actually to deep dive into system design concepts. Because today and in next session, I will cover them just briefly. Most of them actually require quite deep dive. That's what our target with Shailaja. Yeah, so let's get started. System requirements. Usually, during the system design interview, or when you are designing the feature or like product, you come to the system requirements. And system requirements, we're usually dividing on 2 groups. It's functional requirements, and it is non-functional requirements. What is the functional requirements? It's what the system should do. This describes the behavior and features and interaction of the system from the users and IP perspective. So, for example, if we will talk for today's session, I decided to take URL shortening like bit.ly. Just who doesn't know, just make yourself audible and ask. I will just briefly explain what is this, if someone on the call doesn't know the system.
Can you explain it, please?
Yeah, sure. So basically, the idea is this one. Oh. Here, for example, I have like, let me search something. For example, this one actually good one. See, I have this link, which is I just copy from here. Do you see it, right? Just admit. I have a long link. And now I want to share this link with someone else. And I make it's here. I pass this link and I ask to generate it. Just 1 second. And it will create for me just very small short link, which is I can easily share. Instead of sharing this one big, I will share this one, and it will be redirect me to the link which is I provided as a long one. Is it clear now?
Yeah, thank you.
Okay, cool. So this is very straightforward and very simple system design, and it's quite popular during the system design interview. So I just talk it's just randomly. There is nothing specific around. So based on this system, I will just will refer to this. So what could be the functional requirements to this system? First, it should accept a long URL, as I showed, and return a short one. Then when I paste this short URL, it should redirect me to the original one. A part of it, it's nice to have track clicks analytics, like how many times this short URL was actually clicked. For some business, it's neat. Just for some business, let's not go deep into this. So basically, we need to gather some analytics. And sometimes we can support, we can have this custom feature where we're supporting, actually, we want to support some custom short URL. For example, we have company, which is women coding community, and we want that women coding community being part of this short URL. This one is functional requirements to the our system. Is it clear? Okay, cool. Now let's move to the non-functional requirements. How well the system performs its functions, the function which is we defined. This describes quality attributes like performance, scalability, availability, security, etc. So in case of URL shortening, we can define these non-functional requirements. It should be scalable. Also, scalable will be covered in the next session, but availability will be covered in this session. Don't hesitate to ask me some questions, but I will try to answer them and that you have some understanding. So non-functional requirements, which is we can define during the system design URL shortening question. So it should be scalable. Means it should serve traffic like 100 million users or 1 billion requests a day. Availability, it should be highly available. Means when we're sending requests, we want to receive when we're sending requests, like we want to receive short URL. It should respond with the short URL. It should not answer us with 5x or something like service is not available. And also we want to have the system fast. Means once we requested modified URL, we want to receive this answer very quickly, like it was here. It was like in microseconds. This is our non-functional requirements. So now, when we define it, why we need these functional requirements and non-functional requirements, I will explain how we start thinking during the system design interview, or when we're just defining some system design feature on the at the workplace. So let's start from non-functional requirements. As we define scalability, availability, and performance, let's walk through how to address using system design principles or concepts. First, scalability. How do we make the system handle 1 billion short URLs or 100 QPS? Why 10K QPS? Can someone answer now? How we find from 1 billion short URLs and we ended up with 10K QPS? Okay, so basically, when during the interview, yes, query per second, it means. Here we have it's just off top, we will cover this topic as well. This is back to envelope. This is part back to the envelope during the system design, where we have input data, like 1 billion requests a day, but we actually want to find how many requests per second or query per second we have per second, not per day and not per month. This is very important to understand because we can have, so for example, we have traffic, which is defined per month, but if it's spiky, and for example, so per month, for example, we have like 300 traffics. But when we have calculation, we are ending up that it is just 500 requests per second. So it's nothing actually. It's nothing in the scale of system design, usually 500 requests per second. But if we will calculate and we will figure it out that there is like 10,000 requests per second, we can have in mind that, for example, one host can hold like 4,000 requests per second. But if we make the calculation, which was from the input, and we figure it out that there is 10,000 RPS per second, we start to thinking, okay, then we need more than one machine or more than one host. So this is a kind of off top. We will cover it deeply as a part of back to envelope. Yeah, so as input data, we have a request per day. But now when I'm asking about the scalability, I make the calculation from 1 billion queries per day. I make the calculation. Basically, I just divided 1 billion on what will be. This will be nearly 10,000, I believe, second. We usually circle it. We will have 10K per second. So usually, when we're defining the non-functional requirements, we have input data per month or per day. We need to find out how it will per second. It is kind of off top, but yeah.
I wanted to add, because many people are mainly focusing on these numbers, but the main intent of the Lilia is, when we are starting a system design, first we need to understand functionally what are the features we want to support, and probably that's place where we want to simplify your design, negotiate with your interviewer what you really want to focus on in your short interview. For example, if you are developing a messaging app, if you want to first start focusing on a simpler one with for a small one-on-one messaging, and if there is a time left over, that's when you probably want to focus on group messaging, etc. So there's a reason negotiating or discussing the function requirements with interviewer is very important. And the non-functional requirement is where you wanted to understand how much scale you wanted to support. So during the calculations, probably you wanted to add many machines and you want to add a cache. Then interviewer probably will ask why. What do you want to cache? What do you want machines? These many machines. How much memory you need? How much disk space you need? So you need to justify why you need. For example, if you say that I need to support 1 petabyte of the disk space, then you probably will ask you why. So there's a reason to justify those numbers. That's where you focus on non-functional requirements. And so initially, when you are discussing functional non-functional requirements, that sets up the context for your rest of the interview. There's a reason this is important. So in this particular example, Lilia is taking this shortening of the URL. So forget about these numbers for a while. We will have a separate sessions just for how to calculate these numbers. These are not as simple as it looks. There are a lot many calculations involved. What is the disk read time latency? Usually, what is the cache latency? So all these numbers we need to keep in mind and make a calculation. So for now, we just focus on what are the non-functional requirements and why we need to focus on them.
Yeah, thank you so much. So yeah, let's focus. We have 3 non-functional requirements and how our thoughts should start work during the system design interview. So first, scalability. How to we should answer how do we make the system handle this kind of input from the interviewer, who is provided the approximately the estimation of the traffic, which is you have to expect. So yes, this is kind of digit was a little bit off top. It's quite complicated part of system design, and we will cover it in deep just in another session. So okay, what next? We have input. We know that our system should be scalable. Now we should answer. It should be scalable for reads, or it should be scalable for writes. What I mean here under reads or under writes. Reads, it's when you are sharing your shared URL and your clients or your friends just click on it and redirect to your initial link. This is we calling read. When we're speaking about write, it's when you just came to this system and ask for a short URL. This is the write. In this kind of system, if you will think for URL shortening, usually reads vastly outnumbers the writes. Because every time someone click, as I explained it, short URL, we read this mapping. And we rarely compare to read, we actually write. So means we should scale this system for reads. These 2 things, which is you can catch up already from your non-functional requirement. You know that you need to scale the system, and you should think what you should scale. You should scale reads or writes, or you should scale both. Both is also possible. There is different system like messaging system. Messaging system equally read and write. So if you have some questions, just you can ask. What now I'm moving, what system design concepts can meet scalability requirements for this system? One of the system design concepts which will meet our scalability requirements is horizontal partitioning sharding, which is briefly was also touched on our previous session meetup. Another one, it's always when we want to scale for it, we usually use caching layer. It could be Redis, Memcache, or whatever cache can. Usually, it is the most popular. It is read on Memcache, but you don't need to know the name first of Redis or Memcache. You can just tell an interviewer that you need just a caching layer. So to cache hot short links. And another one, stateless app server. Why stateless app servers? Because we have logic which should take short URL and make redirection to the long URL. For this, we need this redirection logic, which is quite small. It could be implemented as a part of service, your service or system, and it could be deployed to EC2 instance and can be placed somewhere, for example, in a region or in some data centers. Usually when company has data centers, they have not that many data centers across the world. But there is another solution which exists. You can use, I didn't define it here. So basically, you can use AWS Lambda service, which is edge compute, which has capability to run small piece of code, like a redirection logic. It should be like a 5-6 piece of code, which is you can actually place close to the users. And also, it could be stateless. It should be stateless. And when you have such of logic and you're using edge compute, you can easily scale based on the traffic demand. So, for example, if you see that your traffic pattern is growing, and you can automatically, whoever work with any cloud technologies, they know that it could be automatically scaled. Or it could be done with Kubernetes, who work with on-prem solution. So, and the fourth one here, it is actually will help us.
Ask a question, please. Why do we need this to be stateless?
Because you need to serve traffic, you need to route them, and it's easier to route traffic when the server is stateless, and also it's very easy to scale it with the stateless server. For example, if one server goes down, it goes down because it's stateless. You don't need to redirect. You don't need to have this complexity, like to preserve state of the system and share it with, for example, with the another server. Does it make sense?
Yeah, makes sense. Thank you.
Okay, and the fourth one, it is actually for sharing for the scaling rise, when we can pre-generate keys. Keys, in this case, I mean this one. So you can easily pre-generate, and if you have, for example, a traffic pattern, which is all of a sudden we start receive traffic on creating new URLs, then you have pre-generated key, and you don't spend time on actual pre-generating them. Like I also didn't add here. So basically, when you generate it, you also need to deal with some collisions, with some duplication. That you should be ensured that all your keys, which is you provided for short URL, it should be unique one. So in order to omit all this complexity, you can pre-generate them in advance. In this case, we will scale for writes. Shaila, if you want to add something here before I will move to low latency.
No, this one I think particular to this particular example. So leave it aside and just focus on functional, non-functional now.
Okay. So another one, we want that our system is the new URL key temporary. No, it is not. It is not temporary. So basically, in this case, you will save, and there is I don't know what is how long they will preserve, but I don't think that it is temporarily.
Is the pre-generation for to improve write latency? Is that the reason why we are pre-generating?
Yes, to improve write latency when you actually generate a new URL.
Okay, thank you.
Okay, now moving on, we'll accept people. We want that our system will be fast. So what means fast? It also could be like low latency as well. or just fast. Means we should receive a response quite quickly on our request. I add some points where we can actually introduce our latency. By introducing latency, I mean when we can add some complexity and some. So if our target is we want our request and no, actually redirect happen in 200 microseconds, then we should reduce our latency where we're spending the most of time. So one of the bottlenecks where we can potentially spend time, it could be, I just defined it some, it could be more. So it could be DNS lookup, or it could be app server logic, which is where I just described. And it could be we can spend time on DB or cache fetching. Here are some numbers, abstract numbers, where we can. So Redis and memory cache is usually take 5 microsecond. K-value store, for example, like DynamoDB, is usually 520 microsecond. If we're speaking about relational database, in this case, it could be go to up 100 microseconds. So, and when we have target that we want to redirect actually with 200 microseconds, we can start to think that probably relation database is not a good fit to this system design, right? Because we will spend some time on this. What is this? This second, this is a millisecond, I believe. Yes, it is millisecond. Yeah, sorry, it is 200 milliseconds. No, you don't need, it's just for you to understand how, there is some particular numbers, which is you need to know to understand that we'll also cover a little bit in the previous session, where we covered that, for example, read from memory is faster and read from disk is usually long, it's not that fast. And also when we come to the relational database, all join requests usually take a lot of time. So you should just understand for yourself what works quickly. And when, for example, from interviewer in the input, you will receive like milliseconds latency, you just think, okay, if there is milliseconds, then probably relation database won't fit in this system design. A part of it, you can go further and just to think. For example, as I explained it before, we have some code logic with redirection. We can pre-compute this logic. It's usually, for example, you have one request, which is requested this short URL, and you did one-time redirection, and will be landed another request or 100 of this request for the same URL. You can think, okay, maybe for reducing latency, it's nice to just to pre-compute this result and save in the cache. This is one of the way to think in this case as well, how you can reduce latency. Yes, network latency as well. Yes, because every time when you see here 2 microseconds, you also should think about the round trip. And it's usually why we're targeting when we're speaking about latency or a fast request, we usually think that that machine from which we are serving this content or serving this request, it should be as close as possible to the customer. This something concept which is we also will dive deep. It will be like edge computing, or it will be a cache, or it will be CDN. This is some system designs concepts which will help in terms of fast performance and low latency. Yes, yes.
One quick question. Could you explain why there is a latency introduced in application server logging and why that is useful to fulfilling our functional requirement? Like, where does logging, how does logging impact this design?
What? Where did I app server logic? There is
Sorry.
here it is logic. Sorry, it is just typo.
Okay.
App server logic. I mean the logic which is redirect. Actually, take as input a short one and redirect to the long one. It is logic.
Okay, cool. Thank you.
Okay, what system design concepts will help to meet fast response? So as I mentioned, it should be a geo-replication like CDN. CDN is particular cache. Also, yes, as I told before, it could be used AWS H, AWS Lambda H with this redirection logic, or some analogies, which is Cloudflare workers. Again, you don't need to know these technologies, but you should understand that we can what is the key here, and especially in the context of this system design, that this code logic app server is not necessary to be as a project or as a service, which is we usually develop and deploy on the some machine or EC2 instance. It's quite simple and quick logic, which is could fit in these existing solutions. Okay, also aggressive caching, as I mentioned, fast database, as also I mentioned, you should understand, we will cover this topic like SQL and NoSQL database, and what is the difference. You will know when to use which one. In this case, we need to use NoSQL database, particular key value store, because we don't need any relationship between, and we need fast request. Usually when it comes to performance or latency, we usually are using pre-compute or batching. Yeah. So, and minimal logic in the hot path. This is something also very advanced, I would say. It's usually something which is you not think during the system design, but if you target in some high level, you probably will you want to show like understanding what is the hot path, what is not critical path, etc. Shalaja, do you want to add something at this point?
Yes. Once you are done, I'll scribble on my whiteboard and show them an example, because I want to take a different example to be more clear on this one.
On the low latency, you mean?
Exactly, correct.
You can then share because I'm moving to high availability now.
Are we both allowed to share at the same time?
I can stop sharing and you can share.
Okay.
Sorry, can I ask a quick question on this? Do we have to justify in interviews, even if, let's say, we use NoSQL database, do we have to justify why one NoSQL database is better than the other? And that means we understand, for example, Cassandra or DynamoDB internals somewhat?
Yes.
Actually, it's not about one SQL database versus another. It's about usually the SQL versus NoSQL. It's not because of the numbers. It's because of the different way of modeling the data. For example, NoSQL allows us to model the schema more flexible, whereas the SQL is very strict on the schema, etc. It's not about the numbers. For example, you don't need to really know what are the latency numbers of the Oracle compared to the PostgreSQL. No, it's that's the reason I want to present and show you usually what are the numbers you need to know, and how you want to calculate from there instead of remembering every provider's numbers.
Okay.
Sure.
Actually, Shalaja, I just noticed that it's 20 minutes left. Probably because scalability, I'm covering it just in brief. This will requirements which is will cover in depth. Currently, I'm just explaining what is non-functional and functional requirement and just explaining my thought process. But everything will be covered in depth.
Okay, so I just want to show one table to them, which they need to know and why they need to know. After that, we can switch to high scale.
Yeah. Go.
So these are the usually numbers you need to know. These are nothing to do any provider. these are very generic numbers. You don't need to know exact numbers. For example, in this case, the cache reference, which is zero point 0.5 nanoseconds, you don't need to know exactly zero point 0.5. But on average, this gives an idea how much latency a disk is involved and how much latency a cache is usually involved, memory reference is involved, so on. So I myself don't remember all these numbers unless I'm really designing a real system. But for the interview perspective, I at least know, for example, compared to the disk, cache is at least 10 times or 100 times lesser latency. This kind of overall high level understanding is what needed. And why you need understanding that, let me scribble and show you. Um, yeah. So, for example, in your system, uh, if you're accessing from the database, and your request is coming, the latency is from your end point. For example, we are doing a Google search. When the client user submits a request, it goes all the way to Google servers, does some processing, and sends a response back to the client all the way. This is called latency. Starting from here, starting let's say 0 milliseconds to all the way going go there and coming back. Let's say it is 5 milliseconds. This is called the latency, the time required to serve one request. Now, when the databases or even the normal file system is involved, it is involving a disk read. So when you know approximately how much time a disk read involves, looking at this table, for example, a disk read is approximately reading sequentially from SSD, not SSD, HDD. So it's around 30 milliseconds. So when you are reading from disk, it involves 30 milliseconds. In that case, you can come up with an idea. If the low latency is important for your design, you can say that I will introduce a cache that will require the cache read latencies, ideally main memory reference is around 100 nanoseconds. So how are you improving the numbers? How are you improving the performance, improving the latency? That you can show. And why usually interviewer may not ask you to tell me exact numbers, but they will just probably check why are you introducing the cache here, or why, if you're not introducing the cache, they may ask you what is the latency approximately involved here. But you don't need to know exact numbers. You just need to justify that. Why do you want to have a cache? Why you don't want to have a cache? What is the disk involved, etc. So in this case, if it is a SQL system, and no, it could be anything, Oracle or Postgres, we probably, there is performance differences between each of them. Definitely there are benchmark differences, but you don't need to worry really at that in that one, unless you are implementing real design. In that case, we usually do POC of different systems, take benchmarks and choose the right one. But the system design interview perspective, you don't really worry about. You can just assume that this is a discrete, and usually what is the time involved for a discrete. When you worry about SQL, no SQL is, it is about the database schema, flexibility, the database data modeling. That's when you choose between these, not because of the latency here. Am I clear?
Yeah, that makes sense. Thank you.
Yeah, I will let Lilia to finish her.
Okay. Uh, okay. You don't see my whiteboard now, right? Okay. Okay. Now to high availability and how to ensure that user can always access their links even during the failure. So what does availability mean here? It's that user should be able to redirect from the short URL to the long URL reliably, even during server or zones or DB failure. What is design concepts to meet high availability? It's replication. It could be leader-based, it could be leaderless. We will cover all the type of replications with the pros and cons. Just leader-based replication is usually easier for consistency with control failover, and there is more complexity with leaderless replication. Another design concepts is failover mechanism to meet high availability. Means, for example, we also covered a little bit on the previous session when we have in front of load balancer or health detection mechanism, and the routing traffic depends on the not availability detection. Also, if we detect that, for example, one of the region is currently unavailable, we can fall back to the close region. But it will cause some latency impact. So this is kind of follower mechanism. It could be it could be on different levels in your system design. So redundancy at every layer. So we need redundancy not only on the level of database, we need redundancy on the most of the components in order to meet high availability requirements. It should be on the level of cache if we have cache. It should be on the level of web servers if we have web services. It should be on the level of database. Also use durable storage. So for example, there is different storage. As we discussed, there could be in-memory database, which is doesn't have which doesn't store the data on the disk. Means if the machine will go down for some reason, we will just lose everything what is in memory have been stored. So we need to use durable storage in our system to meet high availability requirements of our system. Okay, and finally, to summarize everything what I was just told. So for scalability in our current system design, we need to focus on partitioning, stateless service, and caching. For availability, we need to add replication, failover, and redundancy layers. And for performance, we optimize latency via caching, geo-replication, and also async processing. Async processing, what I mean here, so as I mentioned before, there is a different path in your system. One of very critical, and if it's required very low latency, you usually want to optimize this path in order to reduce all the complexity, like to have logging as a part where you're meeting some metrics or you're meeting some analytics request. You usually want to do this because analytics and logging is very important in each system. And for this reason, in order to offload the hot path for your request, for critical request, which is required at low latency, you usually do some background process, which is emitting these metrics. That's, I mean here on the async processing. So basically, that's it about non-functional requirements, and I will move quickly to the functional requirements, why we need functional requirements in our system design.
Just ask one quick question about that. So you said multiple redundant layers, right?
Mm-hmm.
Isn't that more for scalability than availability? I mean, it's also useful for scalability, right? Because when you have more multiple
yes, they're overlapping. Yeah, you are right. So basically, yes, replication sometimes used for scale reads when we are allowed to read from the passive replicas. And yes, you're right.
Just one other question regarding async processing. I didn't understand the relation between hot path and asynchronous processing of requests.
As I mentioned, so you have code, right? Which is should be executed. And this code can be executed in a millisecond or can take longer. For example, depends on difficulties of the logic behind of the implementation of this code. So you know your hot and critical path. You know what the function should be responsible for this. And you're doing and you're reducing these boilerplates like emitting logging, emitting analytics into background processors. So basically, inside of code, you're just spawning another threads, which is in the background will do this for you, and will not impact how fast actually executed your main logic. Does it make sense now?
Something like telemetry, you can spin on a new thread and let it continue with telemetric data, but
yes,
at least we serve the requests quickly through finishing the business logic for the users.
Yes, exactly. Instead of waiting while all of them will be finished. Yes.
Okay, thank you.
Yeah. Okay. Functional requirements. When we have functional requirements, it is usually use case, and all our functional requirements will be mapped to our IP design for this system. This is something which is we also will cover in depth, like IP design, because it's also quite a complex topic regarding the IP design. Because it's cover where you like authorization, non-authorization, where you have to include some talking or not talking, where you have to include user ID as a part of your path. So it's also worth to cover in depth as a part of different meetup. So on this, I'm moving. If you have any questions regarding the functional requirements, or Shailaja, if you want to add something.
Yeah, no, go ahead.
Okay. Because yeah, there is like 10 minutes left, but let's today I want to cover terminologies, which is high availability, and we will also cover fault tolerance, resilience, and reliability. I want to add from the beginning that high availability, fault tolerance, and resilience, they are kind of overlapping each other. And all the design, system design concepts, which is well defined under highly availability terminologies, they apply to the fault tolerance, resilience as well. Okay, high availability, as I touched before, and Shailaja also touched, it's about how long system being available. It's about uptime and how long the system was actually down. I mean, how many requests was down. Usually, uptime percentage is measured in nines. There is examples. So if it's 3 nines, it is, for example, nearly like 9 hours downtime per year. 4 nines, this one, and 5 nines is this one. Usually, all services has the uptime percentage. Especially, it's very relevant to the cloud services. They usually have SLA, which is calling service level agreement between a system, between services, and between clients. They provided the minimum uptime to the customer, and if they don't meet, they actually refunded them in some case. So why do system can become unavailable? It could be server crash, it could be data center or network outage, it could be database failure, it could be code bug, memory leak, deployment issue, unexpected load traffic spike like DDoS attack, or you all of a sudden receive traffic from your customer, which is you are not scalable to serve, and it could affect the other customers. This is some reason which is can impact your system availability. Okay, some design concepts that improve availability. It is redundancy, replication, failover mechanism, load balancing, auto-scaling, rate limiting and load shedding. Rate limiting and load shedding will help you because all others terminologies we already briefly touched to some extent, but feel free, please, to ask some questions. Tool you recommend to best get the functional requirements from the user? I will answer a little bit later. So rate limiting and load shedding, it is some tools which is help your system protect from the spike of the traffic. So, for example, if customers send beyond 10K RPS, requests per second, and you know that your system can serve just 4,000 requests per second, then the rest 6,000 requests per second will be dropped. And customer will see 5x. Sometimes he will see another error. I forgot how it's called, but it will be explicitly saying to the customer that we throttle him. and try a little bit later. So backups and snapshots. How to make sure your load balancer is highly available if you decide to use an open source tool like HI proxy. It's also about to adding redundancy. Yes. So basically, you also have load balancer, and you have also redundancy. Like it could be active. It's usually active passive redundancy components. You have one load balancer, and you have components. Another two, for example, load balancer, which is syncing with the leader of load balancer, and they preserve the same state. And for example, if your load balancer is going down, the main one, you just switch to the replica one. Okay. Is it understandable about high availability terminologies? Because I'm moving on to the fault tolerance, resilience, and reliability. Okay. So fault tolerance. Tolerance. Let me. I brought this like in introduction because in my opinion, fault tolerance, resilient, and high availability is sounds a little bit similar, but there is some small nuances between all of them. So as we talk, high availability, it's about ensuring that your system is highly available, but what is the high, in which degree, you usually define it based on the system which is you design it. It means that system is aware that there could be a downtime. When we're speaking about fault tolerance system, our main goal is to zero downtime. In this case, when we're speaking about the resilience terms, we are saying that our system should very quickly recover from any failures and continue to work in the same in the health state. If we will just imagine this system as a plane, then fault tolerance means it's keep flying even if one engine died, because in the sky, if you have a system which is just, for example, plane which is have one engine which is down, you can't just stop flying, right? You need to reach quickly to the point where you can actually could land your plane. So the idea is that if one engine in the plane will go down, there should be any other which is quickly will take it over, and there should not be any downtime. While resilience means it can land safely and be repaired quickly. It means once we have an issue with engine, we can quickly and safely land it and repair it and continue our flight. Reliability is slightly different. It means it gets you to destination on the time and safely every single time, continually. Then means the system is reliable. So at this point, it is understandable about the system, emerging system as your plane.
So I have one question here, Lydia. One is, so if a system is fault tolerant, that is, we have mechanism to continue it running without, even if one or two servers crash, right? And it is resilient, but reliability, let's say, it takes for example, you send a request, it takes too long for you to get the response, but you're not crashing, you're not the server or whatever application is not crashing on you. Would we say it's still highly available in terms of, just because the time is now beyond SLA, but is it still highly available?
It's a good question. You put it right, because reliability, it's mean highly available. Correctness, it means a system you're high available, correct, have correctness, and have correct time. time meaning that your request will be served in acceptable timing. When you're speaking, whether your system is still reliable, even though your request will be served very slow, it's not reliable, but it is highly available.
Okay.
I think I missed the exact question, but usually we take percentile of the timings, time taken for each of the requests. For example, when there are 1,000 requests, sir, probably one request probably sir very fast, one request sir very slow, one request probably going in a medium. So we take a average out of them, the percentile of the numbers, then can choose what is the percentile of an average request as sir. So there is a book, data intensive applications, design of data intensive applications. That book is having very good formulas listed. We will cover them in depth. How do we calculate those percentile and tell exactly what is the reliability? How do we calculate reliability? In fact, even for the availability as well, there are formulas how to calculate them. So we'll go through them. But just because few requests are out of the boundary of the timelines we want to serve, doesn't mean the system is not reliable. We have to take an average percentiles.
So high availability is
No, I think there is also should be some sense of logic. Yes, there is some request which is when we're starting, they can take longer, especially if we have a cache layer. All other requests will be served quickly. But in this case, we're speaking about when we are going beyond the timeout expected for the customer. For example, we are serving request, but we have timeout from the client and client timing out at this point, because the requests take longer than usual. Because even though if the first request take longer, it should be still in the acceptable rate. But there is sometimes system can be so for example, you introduce some bug on the system, and all of a sudden all your requests will take longer than expected. And if there is already configured timeout on the customer, on the client side, all these requests will go down. At this point, it is not reliable system, because customer accept from the system that his traffics, whatever, it could be served within this range of time. Usually it's quicker, but sometimes, yes, there is some cold start, but also customers know that, okay, some of the requests can take longer. But if we're going beyond of this timing of the request, then it means that the system is actually not reliable.
okay. But my main question was, is being reliable part of being highly available, or are these two separate concepts?
Being reliable, it's not being as a part of high availability, but high availability is a part of being reliable. Means your system should be highly available in order to be reliable. Because, for example, your system can be very outperformed, very secure, but it is not available most of the time. Then this system is not reliable, right?
Yes, yes.
This is one of the things. So basically, under reliability, we usually think that a system should be highly available. It should provide the correct result. Means all the time when we're sending one request, we should expect that it will be provide us with correct data. For example, could be cases when the data is corrupted on the server side. In this case, then we will receive some corrupted data and unreliable data from the server. This is one of the things, what is meant under correctness. And another things is time. Time, how long we should wait for the response. Because usually what the client is doing timeout on the end. And if it's coming beyond, quite frequently means system is not reliable.
Okay, yeah, that makes sense. Thank you.
Mm-hmm. Okay. So fault tolerant, as I mentioned, so the goal of fault tolerant system is to have zero downtime. Usually it means that we are also, it's as I mentioned, it's very overlapping with high availability. It's concepts which is used. So it means we need to use system design concepts like redundant server, database replication, retry mechanism, load balancer with health check, or circle breaker. This is another one concept, which is similar to retry mechanism, load shading. We will cover it. In terms of example, in our system, and the URL shortening service has two database replicas. If one fails, the system switch to the others without downtime. It's very important because when it's depend how you configure your replicas. Sometimes, in order to, if we're speaking about leader-based replication, it takes some time just to elect one leader in order to start to serve traffic. And it is we calling downtime already. But in fault tolerant system, we need to design our system the way and replication the way that should be no downtime, or at least there should be downtime which is not visible to the customer. So moving on, what is the resilience? Resilience, as I mentioned, it is a system ability to recover from failure and return to the normal operation. So the key idea is failure may happen, but the system should recover gracefully. So some system design concepts: graceful degradation. It's something related again to critical and non-critical path. So, for example, you have critical logic in your service, but there is some non-critical things like updating configuration or something is happen on your system, and this non-critical path should not affect the main system availability in this case. So you should handle it gracefully. Means the critical path, if it's not affected, it should continue to serve traffic. And you can add some alarms, monitors, or emit some metrics where you will receive any notification from your system that there is some impact on non-critical path. But at this time, your system is serving traffic because some non-critical component is actually went down. Or there could be some automation which just will detect that your non-critical components is go down and try to just replace it or with the some redundancy node. So yeah, health healing infrastructure, as I mentioned, after restart, crash process, when you have your service and it can after restarted. Yeah, this is quite advanced topic. And reliability, as we discussed, so it should be highly available, correct, and include time. So I think I'm finished here. If you have any questions, now is the time. And Shailaja, if you want to add something.
No, I don't have anything. There are some questions in the chat on regarding the load balances and the type of the load balance. We will have a separate session just for the load balances, and then we will discuss about different kind of one. How do we ensure the high availability of them?
Yes, I will share this one whiteboard.
And one small thing that I forgot to mention regarding choosing between SQL and NoSQL databases. We will deep dive on them in the session, but in overall, SQL systems are more read intensive compared to NoSQL systems, which are write intensive. And also, SQL systems usually supports ACID properties and transactions, and NoSQL systems not many. There are few, but not many. So it's not just about the latency on the throughput of the systems. We need to think through different perspective, which one is right for your system. If your system requires ACID properties, then there is no negotiation. You will have to go to the SQL only most of the times. Otherwise, in that if you are not particular about ACID properties, then you can probably choose between SQL and NoSQL depending on the database schema flexibility as well as the either system write intensity or read intensive. But we will have a separate session because that itself is a very big topic altogether.
Yeah. So the idea of today's class, just to sum up everything, I want to describe what is the system requirements why it's important, what is functional, non-functional, and why we will start to learn all these system concepts and next meetups, and why it's important to understand all of them, the concepts, and what is the under which terminologies, under which non-functional requirements they are mappings. Yeah. I think yes, we will create in order that you will have guide. We will split them on like I did today, like high availability. We have these system concepts. On the fault tolerance, we have this system concept. On the performance, we have this system concepts. I think this way it will be more understandable, right?
Just a quick question, Amelia. Just about the meeting, though it's not on the topic. Do we have to register for this this one, Sunday evening every week, or is it only because I realized the same thing on the lead code as well? I'm having to come and go to meetup and register every week for attending this.
I think it's the way, but I will double check and then I will post it because I think it's only the way. But we're using the same link every week.
Yeah. Okay.
Yes.
Okay.
I've got a question.
Sure.
The API has to be idempotent, but what if it does change the state on the database? How do you make it idempotent then?
Can you repeat this one?
I think on one of your slides it says that idempotent. But if you are changing the state on the database, how do you make it idempotent?
I mean, this idempotent related to IPs, right? It's not on the level database.
But so if the query is to update,
it is idempotency. This is the functionality, the features of the IP. So, for example, there is some idempotency IPs and not idempotent. And when you are creating, for example, some resources, and you didn't receive any answer from server, and you keep retrying, you don't want to eventually end up with duplication of these objects in your database. That's why we have these features like idempotent.
Oh, so if it's a post which would update something, how do you make that idempotent? Is that
we will cover it. We will cover it in next topic in next meetups.
Right.
Sure.
So but you can make it idempotent even though it's changing the state. The post. Okay. Post request. Also, is it recorded?
Yes, it is recorded. We will upload and we'll share it.
Great, thank you.
Thank you, folks. Have a good evening.
Thank you very much. It's very useful.
Yeah. Bye, everyone.
Bye.
Thank you a lot for joining.
Thank you. Bye-bye.
Bye-bye.
Hi. Just one question, if I may, because my network went down, so I got kicked out. Are we going to get the slide that you were sharing?
Yes, and also we will upload a recording of this session
in the Slack channel.
Yes.
Okay. Thank you so much. It was an amazing session. Thank you.
Thank you.
How do we get to the Slack channel?
1 second. If you are still not here, I will share one. What to do? Let me.
I posted the link in the chat.
Oh,
I have issues finding it.
Thank you. So yeah, Andrea, you can find the link on the Slack. Oh, on the chat.
Okay, thank you.
Yeah, if you want to ping me again without with idempotency, you can ping me on the Slack as well. If you're still not clear, but we will cover this in depth in next sessions.
Great, thank you.
You're welcome.